questions? Maybe to start, can you explain a bit more what you say, stop the race for skill?
You know, you try to validate your model, which is normal. You develop a model, you want it to be good. But sometimes maybe a vector didn't invade this biological niche yet. So you're going to try to validate your model because the mosquito hasn't been introduced in a country X, Y, or Z. But I think it's still informative to know where it could migrate, where it could survive, if you introduce it. For example, if you look the map for the tiger mosquito, here, there's all sorts of odd results in my simulations. For example, there in Spain, Portugal seems highly suitable, but it's not been detected yet. And here, I show no risk, but there's lots of mosquitoes all across the coast. But I'm pretty sure this is related to, it's a really touristic place all over the coast. It's irrigated a lot. There's lots of swimming pools, residences and stuff. So the rainfall criteria I use here as a mask feature it may be a bit stupid. So what I mean, it's always good to know where things could occur. Instead of, I want to be sure I know that works now, but it might work in a few years if you wait a bit.
Okay, so it's more the potential than
yes,
really.
Yeah.
Okay, but it's complex then to evaluate.
Yeah.
Rainer?
Thanks, Cyril, for a wonderful presentation. You contrasted the statistical with the against the dynamic models, but
yep.
Which one did you use for all these projections? Did you really couple the temperature variable and what the malaria mosquito and the Plasmodium does, and then you coupled this to the climate variable in the future?
Yeah, that's it. Yeah, they're a bit mixed somehow because all the dynamical models we got for malaria, all the relationships have been derived from the lab, and in general you got like a few points at different temperatures, and you always fit some kind of statistical curve for it, and then everybody use that as the truth. So it's a mix of statistics, I would say, and dynamical model. And then after you write, we integrate everything with the temperature for the future, rainfall for the future. We also calibrate the climate future for the future because the models got biases, so you need to calibrate them with the observations, So there's lots of things involved there. And in the exercise for malaria, we had one model was statistical, 4 were dynamical, and 1 was statistical using GDP estimates as well. I didn't talk about that, but yeah.
By the way of fasciolasis, so fasciolasis is still persistent in France in one area, near Limoges, north east of Limoges in what we call the Berry, and the disease is persistent just for traditional beliefs there. So if I accept the idea that the disease life cycle has a lot to see with weather variability and intensive farming, homogenization of landscapes and other drivers are very, very strong drivers, making that the disease has disappeared from Western Europe, except in some regions. So what is your feeling about that?
When we've done that for the EU project, so-called glowworm, there's someone involved on the land management side of things, because you can have some risk across a big region, but from farm to farm, if you don't have a snail, first thing, there's no snail, there's no disease. So you can find large heterogeneity at spatial scale. But we're trying to, I think we published that for Europe, and I'm going to get to publish for the UK. But for the UK, that was interesting because they had 30 years of data, survey data from the veterinary offices. So I could basically plot time series for different regions, and it works okay. It's not brilliant, but it follows the curve. One thing to remember for the UK, works well for the UK also. There's been a method, it's already developed there. They got like a forecast issued by NADIS, it's a system. So the farmers can look, they got their bulletin. Instead of having their weather bulletin, they got their disease, their wormy infectious disease bulletin. So it's not only fasciolosis, you got also nematodes, the one which affect the lambs, I forgot the name, but Nematodus batus, forgot. Yeah, all the nematodes basically. So there's big range, and they're kind of fundable on that. But there's also things we can do. There's also things operationally that are possible. It would be interesting to look at.
I just wanted to know whether you include in your models the climate change migrants, because you have increased travel and trade. It's not just travel and trade because we take the plane or take a bus and visit somebody, like in the developing countries, but you have a lot of migration because of climate change, in search of water, in search of pastures and land. So I was just wondering how you would fit that into your model skill, and whether you'd consider that. Thanks.
We took, there's demographic scenario provided by EASA, the United Nations, you can find numbers. They're always wrong when you look them in the past. They always underestimate what's going on. But we try to use that, but we didn't take into account migration. It's basically you keep the same map, and you just scale it with a number. So it doesn't take into account, migration, urbanization. So there's lots of things to do in there by linking with the population health, the population demographics scientists, I would say. But to my knowledge, at the minute, there's no such data set produced. I mean, it could be whatever. Tomorrow there could be a war. There's going to be millions of people moving from one place to another. Who's going to be able to forecast that?
Okay, so we thank you very much. Okay.